Alright, in this episode, we are now moving on to section 1.2 of Stewart's Calculus, 7th edition textbook, Early Transcendentals, and section 1.2 is entitled A Catalog of Essential Functions, and it basically talks about all the functions that are used to represent models of math and models in the real world. So, I'm just gonna discuss today linear models. Linear models. Yeah, and these are the first functions that everyone learns basically in their life. They're just, you have a graph and a linear function or a linear model is a straight line on the graph with an intercept somewhere. And it just keeps going. Keeps going. And oops, there's two formulas we can use to find or to draw the graph of a linear function, and that is point slope, the point slope formula, and the slope intercept formula. Now, you use point slope when you're given a point on the line and when you know the slope, and you use slope intercept when you're given the intercept and the slope. In both cases, you need slope. So, what is the equation of a linear function? I think you all know it's really easy. Y is equal to mx plus b, where b is the y-intercept and m is the slope. Okay, we have to have an x in there. That's our variable, which tells us where we are on the x-axis, and we have y is equaling everything because that is the result of the function at every point on x. So for this function, the purple magenta line I just drew, if our intervals are spaced out like this, okay, this random graph that I just drew, the y-intercept is where the graph intersects the y-axis. So B is where the graph intersects the y-axis, and that would be 1, 2, 3, 4, 5. So in this case, B is 5. Let's write this down. Y is equal to something x plus 5. And then the slope is rise over run. So it rises, it has a negative slope, so it falls in this case. 1, 2, 3, 4, 5. Falls down 5. So negative 5 over, and then it goes over 1, 2, 3, 4, 5, 6, 7, 8. So the slope for this particular graph that I drew is negative 5/8 x, and then plus 5 for the y-intercept. So that's basically linear models. And if you're given a just bits of information over time, and it adds up to temperature or money you make in a day, profit, something like that. This, I believe the book calls this, I'm looking through the book, an empirical model is when you're given a bunch of points representing real life, circumstances with numbers, and you need to draw the best fit line. And one way you can do that is just draw a line from the very first point to the very last point, and it's going to be straight. And that's one way to do it, but a more accurate way is using a calculator and using a computer somehow. Because as you can see, I don't think this accurately represents the empirical information, or it's not a good empirical model because you have like the majority of the dots are below the line. So that's not really good, but it's a linear function is what is used for an empirical model. So that's all about linear models. In the next video, move on to polynomials. That's going to be fun. So see you then.